Um, Imagine for a second you run a major delivery business. You've just, committed millions to go green.
Right, a massive investment.
Exactly. You buy a brand new fleet of 50 electric vans, you proudly park them in your lot, and then you get a call from the local utility company.
Oh boy, I think I know where this is going.
Yeah, they tell you the necessary infrastructure to actually plug those vans in will be ready in like 2 years.
Wow.
Until then, you essentially have 50 very expensive paperweights. Welcome to the massive infrastructure bottleneck of 2026.
It really is a jarring reality check. I mean, we are long past the early adoption phase of just an individual buying an electric sedan and plugging it into their garage overnight.
Right.
The conversation has fundamentally shifted to industrial scale logistics.
Which is exactly what we are getting into today. Our mission for this deep dive is to really decode this rapid and honestly often chaotic evolution of the electric vehicle ecosystem.
Yeah, because it's changing so fast.
It really is. We are looking at how these massive vehicle networks are powered, how they are managed through software, and how they physically alter the streets of our cities.
Exactly.
For you listening, whether you manage a commercial fleet, maybe you're looking to invest in urban infrastructure, or you are just insanely curious about how the world is being rewired right under your feet, this deep dive is going to connect all those dots.
And to map this out, we are synthesizing some incredible intelligence from across the industry. We're looking at the realities of municipal fleet transitions, specific industry forecasts on charging software, commercial business models.
Oh, and the hardware specs too?
Yes, the raw hardware specs of off-grid power generation. We've got a 2026 clean fleet transition plan from New York City, a prediction report from Drivers, a business plan guide from Luxman Energy, and operational details from SparkCharge.
It's a great stack of sources, and I want to start with the absolute vanguard of this transition, which has to be municipal fleets. I look at a sprawling, complex city like New York, and I just assume it is going to take, I don't know, decades to get all their municipal vehicles running on electricity.
You'd think so, yeah.
Where do they actually stand in this process right now?
Well, the scale of the New York City Department of Citywide Administrative Services, or DSAC, is unmatched in the U.S. They operate a fleet of over 22,000 units.
That's massive.
It is, but they aren't waiting decades. Right now, they already have over 5,700 electric vehicles and 406 DC fast chargers deployed.
Oh, wow, already.
Yeah, and when a fleet of that magnitude makes a move, it acts as a gravitational pull on the entire commercial market. Manufacturers basically have no choice but to adapt to their purchasing standards.
But how do they even evaluate a purchase like that? I mean, they can't just scroll through an online catalog and click add to cart for a garbage truck.
No, definitely not. They use a strict three-tier readiness framework. It's incredibly pragmatic.
Okay.
So Tier 1 means the technology is commercially viable and ready to deploy right now or within 3 years. Tier 2 is 3 to 5 years out.
Got it.
And Tier 3 means it's 5+ years away, essentially still in the experimental phase.
Okay, so where does most of the fleet sit?
Well, the most revealing data point from their 2026 transition plan is that a massive 86% of New York City's on-road vehicles are now viable for electrification within 5 years.
Wait, really? 86%?
Yeah, and even more critically, 61% are sitting right there in Tier 1.
That is a staggering jump from just a few years ago. What changed in the manufacturing pipeline to push so many vehicles into Tier 1?
It's a major shift in who is actually making the vehicles.
Because I remember a wave of specialized EV startups a few years back promising to revolutionize the commercial space, but a lot of them seemed to quietly vanish.
Well, they didn't just vanish, many faced bankruptcy.
Oh, right.
Those startups were trying to build what we call vocational EVs, so vehicles designed for a specific trade, like a bucket truck for line workers or a refrigerated delivery van.
Sure.
The problem is that while a startup can engineer a brilliant prototype in a workshop, scaling that hardware into mass production is brutally difficult.
Right, they don't have the factories?
Exactly. They lacked the billion-dollar supply chains and the massive robotic assembly lines required to build thousands of specialized trucks at a profit.
So the legacy automakers just stepped in and took over the sandbox.
Precisely. The established giants of the auto industry, companies like Ford and General Motors, they basically watched the startup stumble, learned from the engineering, and then leveraged their massive manufacturing footprints.
That makes sense.
Now, vehicles like the Chevrolet Silverado EV are firmly entrenched in that Tier 1 category. Legacy crossover SUVs alone make up 40% of all the Tier 1 light-duty options for the city.
Okay, let's unpack this. I like to think of a city's fleet like a massive immune system.
Okay, I like that.
You can easily swap out the white blood cells, the light-duty sedans, and the inspector vehicles buzzing around, but upgrading the heavy bones like fire trucks is much harder because they absolutely cannot afford to run out of juice mid-emergency.
Yes, that is the perfect way to look at it. The heavy-duty challenge is the ultimate hurdle. We are talking about specialized vocational vehicles like snowplows and fire ladder trucks.
Right, totally different beast.
Exactly. A snowplow isn't just commuting, it is forcefully pushing tons of wet, heavy snow in freezing temperatures, often for a 12-hour uninterrupted shift.
Yeah.
And a fire truck might arrive at a four-alarm blaze and need to pump massive volumes of water continuously for days.
If a fire truck runs out of battery mid-emergency, the entire system collapses.
Which is why pure battery electric technology simply cannot meet the operational requirements for those Tier 3 vehicles yet. You cannot tell a raging fire to wait 30 minutes while the ladder truck plugs into a fast charger.
Right.
Redundancy in emergency response is just non-negotiable.
So how does a city mandate zero emissions without compromising public safety?
Well, what's fascinating here is how the industry is bridging this gap with ERVs, extended range electric vehicles.
Okay, how is that different from a hybrid?
This architecture is vital for heavy-duty applications. In a standard plug-in hybrid, both the gas engine and the electric motor are mechanically connected to the wheels, right? Either one can drive the truck.
Right.
In an EREV, the vehicle is propelled entirely by the electric motor. It is, for all intents and purposes, an electric vehicle.
But it still has a combustion engine hidden in there somewhere.
It does. It carries an internal combustion engine on board, but its sole function is to act as a localized generator.
Oh, interesting.
It never drives the wheels directly. It simply generates electricity to recharge the battery while the vehicle is operating.
So it's basically carrying its own power plant.
Exactly. This gives a municipality the silent, zero-emission operation of an EV during normal transit, but provides a critical fail-safe redundancy for when that fire truck has to pump water for 48 hours straight.
That makes total sense. You get the environmental win without risking the structural integrity of the city's emergency response. But let's follow the logical progression here. Let's say you figure out the vehicles. You secure EREVs for the fire department. You buy thousands of Tier 1 light-duty vans for the inspectors.
Right, you've got the fleet.
You park them all in your brand-new centralized city depot. We hit that scenario I mentioned at the very beginning of the show. You have to plug them in.
And this is where we encounter the ultimate bottleneck, the utility grid itself.
Right.
Upgrading a municipal power grid to handle a massive commercial EV depot or a heavy construction site is an agonizingly slow process. We are talking about an 18 to 24-month delay.
Wait, why does it take 2 years to get electricity to a parking lot? We've had power lines for a century.
Because you aren't just tapping into a nearby telephone pole. Pumping high-speed electricity into 50 delivery vans simultaneously requires industrial-level voltage.
So it's an infrastructure issue.
Massive infrastructure. That means trenching through city concrete, securing complex municipal permits, dealing with global supply chain shortages for high-capacity transformers, and physically rewiring the local substation. An organization can have the entire budget approved and the fleet sitting on the asphalt, but they are completely paralyzed waiting for the utility company to deliver the power.
Here's where it gets really interesting. Wait, so if a company wants to go green today, the actual utility grid is the enemy.
In a way, yes.
That's like buying a brand new smartphone and realizing the only compatible charger is locked in a bank vault that takes 2 years to open.
That is a very accurate comparison, and it's why the market is adapting in a really fascinating way.
Right. This is where the spark charge source comes in.
Yes. Looking at their operational specs, they are essentially telling businesses to completely ignore the utility grid. They are pioneering a model called Charging as a Service, or CAW.
Okay, go.
Instead of waiting 2 years to pull power from the ground, they will literally drop a temporary power plant onto your property in as little as 7 days.
Wait, 7 days. We aren't talking about a couple of portable gas generators, are we?
Not at all. It is a radical circumvention of traditional infrastructure. They are physically deploying mobile generation and battery hardware directly to the site.
Right. The report mentions power hub generation, which outputs 5+ megawatts. To put that in context for you listening, 5 megawatts is enough power to run several thousand homes simultaneously.
It's massive power.
And they pair that massive generation with BS battery energy storage systems, which hold over 1,000 kilowatt hours of capacity.
The mechanics of it are brilliant for peak shaving. They can bank energy into those massive batteries during off-peak hours when power is cheap, or generate it on-site and then unleash it to charge autonomous vehicles or heavy construction equipment at blistering speeds.
Entirely insulated from the local grid's limitations.
Exactly.
But let me push back on this because it sounds incredibly expensive. If I'm a business owner trying to green my fleet, circumventing the grid with massive on-site batteries sounds like a logistical nightmare. How does that company justify that on a balance sheet?
Well, the balance sheet is exactly why charging as a service is surging in popularity. Really? Yeah, if a business waits for the traditional grid upgrade, they are facing a catastrophic CapEx capital expenditure.
Right, big upfront costs.
Huge.
Yeah.
They have to pay millions up front for the trenching, the concrete pouring, the transformers, and the physical chargers themselves, all before a single van gets charged. CAS completely shifts that financial burden. It converts a massive, unpredictable CapEx into a predictable OpEx operational expenditure.
Oh, so it functions just like a subscription service for energy.
Fundamentally, yes. You pay a predictable rate per kilowatt hour of energy actually delivered to your vehicles.
And you don't have to maintain it.
Nope. The provider retains ownership of the hardware. They monitor it, they maintain it, and they upgrade it. The industry forecasts from Drivers explicitly predict this model will explode by 2026 for retailers and logistics fleets who want the benefits of EV charging but refuse to take on the liabilities of managing heavy electrical infrastructure.
Okay, so if off-grid solutions and cars remove the infrastructure hurdle, it means businesses can finally start treating EV charging as core commercial infrastructure rather than just, a frustrating environmental mandate.
Exactly. It changes the whole mindset.
Which leads perfectly into the Luxman Energy business plan. Because once you remove the grid bottleneck, the ultimate question for any real estate developer or business owner is, how do you actually turn a profit on a plug?
And that is the million-dollar question. The instinct for most new investors is to simply buy the fastest, most powerful chargers available, assuming speed equals premium pricing.
Faster is better, right?
You'd think so, but the Luxman Guide emphasizes that this approach usually leads to financial ruin.
Really?
Yeah. The entire economic viability of a charging station hinges on a single behavioral metric: dwell time.
Dwell time. Literally, the amount of time the human being attached to the vehicle is going to be parked at that specific location.
Exactly. You have to perfectly match the charging hardware to the human behavior occurring at that site. You generally have two paths: AC charging and DC fast charging.
Let's break those down.
So AC chargers typically deliver between 7 to 22 kilowatts. The hardware is relatively inexpensive and installation is straightforward.
Okay.
They are the optimal choice for long dwell locations.
So like a hotel parking lot, an apartment complex, or a corporate office park where employees leave their cars untouched for 8 hours.
Precisely. In those long dwell scenarios, the driver does not need, nor do they want to pay a premium for, a battery filled in 20 minutes.
Right.
Conversely, you have DC fast chargers. These range from 60 kilowatts up to 240 kilowatts, with Drevas reporting next-generation systems delivering 350 kilowatts and above.
That is incredibly fast.
It is, but they are incredibly expensive units that demand massive electrical capacity. They are exclusively for short-dwell locations like highway rest stops or high-turnaround commercial depots.
I always explain this using a restaurant analogy. So AC charging is like a sit-down, multi-course meal, and DC fast charging is a drive-through.
That's a great way to put it.
If you build a high-speed drive-through window at a fancy overnight hotel, it makes no sense and ruins your return on investment. You're burning massive capital to provide a speed that your overnight customers don't actually need.
Yes. That behavioral mismatch is the #1 reason commercial charging stations fail.
Wow.
And if we connect this to the bigger picture, Lexman points out that selecting the right hardware is only half the battle. To run a profitable network, you need an intelligent software backbone, specifically OCPP, Open Charge Point Protocol.
This is essentially the operating system for the chargers, right?
It is the universal language that allows the charging station to communicate with the central management system.
What does that actually let you do?
Well, OCPP allows an operator to manage billing remotely, monitor hardware health in real time, and control dynamic pricing. But even with the best software, Luxman heavily stresses that you cannot break ground without deep demographic research.
Interesting. What kind of demographics dictate charging success?
Housing types are the biggest indicator.
How so?
Well, people living in single-family suburban homes typically install their own AC chargers in their garages. Right.
Sure, they just plug in at home.
Exactly. They almost never use public infrastructure near their houses. However, residents in dense urban apartments have zero access to private garages.
Right.
They rely entirely on public networks. If you deploy expensive DC fast chargers in a suburban neighborhood of single-family homes, they will literally just gather dust.
That makes total sense.
You have to place them near apartment hubs, employment centers, or major transit corridors.
Okay, so let's zoom out and look at what we've built so far. We've got 350 kilowatt DC chargers pulling massive power at highway stops. We have
Whoa.
mobile off-grid batteries powering construction sites. We have hotels managing banks of AC chargers overnight.
It's a complex web.
The flow of electricity across a city is no longer a steady, predictable hum. It has become incredibly erratic, defined by massive, sudden spikes in demand.
Which forces the underlying energy grid to evolve. We are transitioning from a passive electrical grid that simply pushes power in one direction to a highly active, digitized, two-way energy network.
Right, and the Drivese report points out that human operators can't manage this level of complexity anymore. Artificial intelligence is stepping in as the traffic cop for energy management.
AI is absolutely essential for this.
And one of the most critical things AI does is mitigate what are called demand charges. Can you explain those?
Demand charges are the hidden killers of commercial electrification. Utility companies don't just charge a business for the total amount of electricity they use in a month, they also monitor for peak usage.
Okay.
If a commercial depot plugs in 50 vans at the exact same moment on a hot summer afternoon, the power draw spikes massively.
Right.
The utility company penalizes that brief, intense strain on the grid with exorbitant financial fees known as demand charges.
So how does AI prevent a company from getting hit with a massive penalty?
The AI continuously monitors the facility's total power consumption in real time. If the depot plugs in too many vehicles and approaches that demand charge threshold, the AI automatically intervenes.
It just cuts the power.
Not completely. It subtly throttles down the power flowing to the vehicles, spreading the charging load out over several hours to ensure the power spike never triggers the utility penalty.
Oh, that's smart.
The vehicles still get fully charged by morning, but the business avoids a crippling electricity bill.
That is brilliant optimization.
Yeah.
But the part of the Drive's forecast that genuinely blew my mind is VDG, vehicle-to-grid technology.
Oh, V2G is a fundamental paradigm shift in how we define a vehicle.
Truly.
Historically, a car or truck has always been a consumer of energy. You put fuel into it, it burns it, end of story.
Right.
With bidirectional charging hardware, these vehicles aren't just taking energy from the grid, they are capable of pushing stored energy back out.
So what does this all mean? The vehicle isn't just transportation anymore. It is essentially a mobile, heavy-duty battery pack on wheels that can play the stock market with electricity.
Exactly. Fleet managers are treating them as active financial assets. Imagine a fleet of 50 electric school buses.
Okay.
They do their morning route, and then they sit completely idle in a parking lot, fully charged, for the entire middle of the day.
Right, just baking in the sun.
Under a V2G model, that fleet functions as a virtual power plant.
Paint that picture for us. How does a virtual power plant actually generate revenue?
Let's say a severe heat wave hits the city at 3:00 p.m., everyone's air conditioning is running on max, the utility grid is buckling under the strain, and wholesale electricity prices skyrocket.
Prime time for energy.
Exactly. The AI management software sees this market spike. It signals the idle school buses to discharge 20% of their stored battery power back into the grid, selling it to the utility company at a massive premium to help prevent a brownout. Later that night at 2:00 a.m., when city power demand drops and electricity becomes incredibly cheap, the buses quietly recharge themselves for the next morning.
They literally buy low and sell high while just parked. That is incredible.
It's a game changer.
But as a consumer or even a hired fleet driver, I hear all of this AI throttling, bidirectional charging, dynamic pricing, and it sounds wildly complicated. I just want to plug a cable into a port and walk away.
Yeah, this raises an important question regarding the driver experience. For this complex ecosystem to function at scale, the underlying chaos must be completely invisible to the user.
Definitely.
We desperately need industry consolidation and software interoperability. A commercial truck driver should not need 12 different smartphone apps and a keychain full of RFID cards just to travel across 3 states.
That sounds miserable.
It is. So seamless roaming agreements between competing charging networks are becoming the gold standard for fleet management.
Drivers also notes that for certain sectors of the commercial industry, purely plugging in might never be the silver bullet, right? They are tracking the rise of multi-fuel hubs.
Specifically integrating hydrogen fuel cells alongside battery electric infrastructure.
Why hydrogen?
For long haul, heavy-duty trucking, the massive 18-wheelers crossing continents, the sheer physical weight of the batteries required to achieve that range drastically reduces the amount of profitable cargo the truck can legally carry.
Because the truck is too heavy.
Right. In those specific high-mileage use cases, hydrogen fuel cells offer the necessary range and rapid refueling times without the weight penalty.
So it's about having options.
Exactly. The highway stop of the future will be a multi-fuel hub offering traditional diesel, ultra-fast DC electric charging, and hydrogen, all managed by AI to balance the energy load of the site.
Okay, so we have covered the off-grid deployment, the economics of dwell time, and the AI managing these virtual power plants.
We've covered a lot.
We have. But let's bring this all back down to the asphalt. What actually happens when the rubber physically meets the road?
Good question.
Because going back to that New York City transition plan, they detail the literal physical impact these electric vehicles have on city streets. And they frame it around this fascinating concept called the safety sustainability nexus.
Yes, the safety sustainability nexus. It's a profound realization for urban planners.
What exactly is it?
It is the data-driven discovery that technologies engineered specifically to reduce carbon emissions inherently end up saving human lives on the street.
And vice versa, right.
Exactly. Technologies designed strictly for pedestrian safety almost always result in massive energy savings.
I love this idea of nexus. We usually think of green initiatives and safety initiatives as two totally different departments fighting for city budget. But it turns out taking your foot off the gas to save battery might literally save a pedestrian's life.
That's exactly it. The prime example in the report is IC Intelligent Speed Assistance.
Right. How does that work?
It's a software tool that uses real-time GPS and local speed limit data to physically prevent a vehicle from accelerating past the legal limit.
Oh, wow. It physically stops you.
Yeah. It was designed purely as a safety mechanism to support Vision Zero, the multinational urban project aimed at completely eliminating traffic fatalities and severe injuries.
But when New York City deployed IASA to stop speeding, they found an unexpected environmental benefit, didn't they?
They did. By forcibly smoothing out the driving behavior, preventing drivers from aggressively mashing the accelerator just to slam on the brakes at the very next red light. IASA actually improved the electric vehicle's energy economy by about 6%.
That's significant for a whole fleet.
It really is. It turns out forcing a driver to drive safely is a highly valuable metric for fleet operators looking to stretch their battery range.
The report also highlights the necessity of right-sizing fleets.
Yes.
This means analyzing the specific job and deploying the smallest possible vehicle capable of performing the task.
Exactly. A compact electric transit van consumes significantly less energy than a full-size pickup truck, which obviously hits the sustainability goal.
Right.
But structurally, that compact van also has a much lower, less lethal point of physical impact. If a pedestrian is struck by a lowered van with a high-visibility cab, rather than a lifted, heavy-duty pickup with massive blind zones, their probability of survival increases exponentially.
Why is the city placing such an intense emphasis on this safety nexus right now? Are EVs inherently more dangerous to pedestrians?
Well, the danger stems from a new physics problem introduced by the transition, and that's weight.
The batteries.
Yes, lithium-ion battery packs are incredibly dense. An electric pickup truck can easily weigh 3,000 to 4,000 pounds more than its exact gas-powered equivalent.
That is a staggering amount of extra mass moving down a residential street.
Exactly. In the event of a collision, that extra mass translates directly into significantly higher kinetic impact force.
Physics.
Physics. Therefore, software tools like intelligent speed assistance, aggressive regenerative braking systems, and redesigned high-vision cabs are not just luxury add-ons.
They're essential.
They are absolute vital prerequisites to safely deploying these massive electric vehicles into crowded, unpredictable urban environments. You have to actively offset the kinetic danger of the battery weight with superior automated safety technology.
So you solve the localized emissions problem, but you have to immediately manage the physical momentum problem you created in the process.
Exactly.
It requires a completely holistic view of the vehicle, treating it as an active participant within the urban environment rather than just a tool to move cargo from point A to point B.
It really forces cities to redesign their streets and their operational mandates simultaneously.
Which perfectly brings us to our final thought for today.
Okay.
Throughout this deep dive, we have talked extensively about how these massive fleets are entirely dependent on the grid or off-grid solutions like spark charge just to survive and operate.
Right. The flow of power is always directed towards the vehicle.
Exactly. But considering the vehicle-to-grid technology we unpacked earlier, and looking at the sheer massive size of fleets like New York's 5,700 electric vehicles,
Yeah.
what happens when the equation flips?
Oh, I see what you're getting at.
What happens when the city grid needs the vehicles to survive?
It creates a mobile layer of ultimate civic resilience.
Think about it. The next time a massive hurricane or winter storm knocks out a city's central power grid, those vehicles don't just sit idle.
Right.
A fleet of municipal electric vehicles loaded with massive, heavy-duty battery packs could be physically deployed across the city to act as a localized emergency microgrid.
That's an amazing concept.
You could drive 50 electric sanitation trucks directly to a hospital, plug them into the building's infrastructure, and keep the ventilators pumping and the emergency shelters warm until the utility company repairs the main lines.
The vehicle is no longer just a car.
It has become mobile survival infrastructure. It is definitely something to mull over the next time you see a quiet electric delivery van roll past your front door. Thank you for joining us as we decoded these sources today. Remember, the world of tomorrow is being built today, one charge at a time. Keep questioning, keep exploring, and we'll see